All right, everyone, we're back real quick to talk about closure notes for the binomial theorem. The first thing we looked at when looking at the binomial theorem was Pascal's triangle. I would know how to create it, that you start with the little triangle of ones, and then you add the terms above, and always put fresh ones down. So be able to find certain, be able to create the Pascal's triangle. Then also know the connection between Pascal's triangle and NCR, or N-choose-R. Yes, you can use your calculator for these, but I would also know the formula, because sometimes you actually need the formula when there's like letters involved in things. Know how factorials work? That's the exclamation point. Now, expanding binomials. Remember that binomials look like a plus b to the power of n. We might ask you to do a small complete expansion. So like, parentheses 2x minus 5 to the power of 4. You should be able to find every single term, expand it all out. If we were to do that too, we'd probably keep it underneath to the power of 6. Anything past that is kind of a lot of writing, but you could do it. Then we focused on problems where there was, they asked you to find specific terms. So, for example, find the fifth term in this expansion, or find the first term, or the last term, or the middle term, or something like that. Then we started talking about things where you had to find specific terms containing, like, find the coefficient of the term containing x to the 6th, or find the constant term, or the term independent of x. Remember that in my videos, to find these, I usually do the power game to find your R value. And then you can plug your R value back in to the binomial theorem, and then you're good to go. Remember that the binomial theorem, I guess we should have a little bullet for that too. Is n choose R times a to the power of n minus r times b to the power of r. That's every term. Each term looks like this. Just a quick reminder that sometimes you have to work with negative exponents. That means that if there's an x or variable in the denominator, that you have to kick it upstairs and put a negative exponent on it. There's lots of problems that are kind of just more complicated, like they involve fractions, or perhaps there's some sort of multiplier on the outside of the binomial. This is kind of a tough one, but you really just need to understand the concept of what's happening when you expand. How each term looks like this, and that, if there was a multiplier on the outside, that each term would get multiplied by that multiplier. There were a couple problems where you guys had to work backwards to solve for n. Like they gave you a term in some sort of expansion, and then you had to solve for the n value. Those were kind of hard. They involved the definition of choose with the factorial definition, and then they usually involved solving some sort of quadratic. If there were to be a problem like that, it would certainly be the hardest problem on the test, or perhaps even a bonus question. Bonus! All right, guys, that's all I got for you. Pretty short and sweet. Make sure you do every single problem that we've thrown at you, and then you should be ready for the test.